Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about development of surfaces of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a truncated cylinder in which the cylinder has been cut by a cutting plane which happens to be circular in nature over here. So we are required to obtain the development of lateral surfaces of this truncated cylinder over here. So now we can check. The diameter of the cylinder happens to be 40 millimeter and the cylinder is resting on the horizontal plane on its circular base over here, while the top portion of the cylinder has been cut by a circular cutting plane which is going to have the radius of the arc equal to 48 millimeter. So now we know that the height of the cylinder, it happens to be 64 millimeter, and now the arc is going to cut the cylinder in such a way that the starting point of this circular arc onto the extreme edge of this particular cylinder will be starting at 32 millimeter from the top face of this particular cylinder over here. Now the question arises, how do we obtain this circular arc over here into the front view projections over here? So now we know that the radius of the cylinder happens to be 40 millimeter on the horizontal side. Now on the vertical side we can check that intersection of the circular cut section with the cylinder starts at a distance of 32 millimeter from the top face, that is at the midpoint of this edge 1 dash and 1 dash. This arc is going to start intersection with this cylinder over here. Now we have to locate 2 points over here. One point will be the point A dash, which will be the midpoint of the vertical edge 1 dash 1 dash over here, and the second starting point to locate this arc will be this point 7 dash over here. Now we are going to open the arc having radius is equal to 48 millimeter. Now first starting point will be point A dash, that is the midpoint of the edge 1 dash and 1 dash over here. So with this point as the center, that is A dash point as the center, we are going to mark one arc over here having radius is equal to 48 millimeter. Similarly, from this point 7 dash corresponding to the extreme right point which is available with us onto the top face of this cylinder over here. So from the point 7 dash, again we are going to open the compass having radius equal to 48 millimeter. Now another arc we are going to draw through the point 7 dash having radius is equal to 48 millimeter. So wherever the first arc through A dash, it intersects with second arc through the point 7 dash over here, and both of these arcs, they are going to have the radius is equal to 48 millimeter. So this will provide us with the center of the location of this circular cut section plane which is going to have the radius is equal to 48 millimeter. So this way we have been able to locate the center point of this cutting plane arc which is circular in nature. Now from this point of intersection of the two arcs or the center point, now we will again open the compass is equal to 48 millimeter radius. Now when we draw this arc using this point as the center point, now we will be able to obtain the orientation of the circular cutting plane into the front view projections over here. So now with this information we are required to obtain the development of the lateral surface of this truncated cylinder over here. So let us proceed with the construction of the orthographic projections of the cylinder which has been cut by a circular cut section plane over here. So now we know that the radius of the cylinder happens to be 40 millimeter over here. Now we have drawn a circular projection having diameter is equal to 40 millimeter onto the horizontal plane over here. And now we have divided this circular projection into 12 equal parts. That is 12 sectors we have obtained over here. Each sector will be having the included sector angle of 30 degree over here. Now there are 12 points corresponding to the cylinder top face and 12 points will be available with us corresponding to the base of the cylinder. So the red points, that is 1, 1, 2, 1, 3, 1 and up to 12 1 points over here. So these 12 points marked with red color and having suffix 1 over here. So these 12 points, they represent 12 points corresponding to the base of this cylinder, whereas the points which have been marked with black color, that is points 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these 12 points, they represent the points corresponding to the top face of this particular cylinder over here. So now from these 12 points of the base and the 12 points corresponding to the top face, now we have to obtain the front view projections over here. So we know that the height of the cylinder happens to be 64 millimeter. So once we know the axis height or the height of the cylinder as 64 millimeter, so now the front view projections of the cylinder we have been able to obtain over here. So now we have got 12 vertical generators corresponding to the cylinder we have been able to obtain, so that the multiple cut section points onto all of these generators we will be able to locate corresponding to the circular cut section over here. Now we know that this cutting plane, it starts intersection with the leftmost vertical edge, that is 1 dash 1 1 dash at the point midpoint of the vertical edge or the vertical generator over here. So this point we are going to mark as A dash. This point is 7 dash. So we know that the radius of this arc happens to be 48 millimeter. But we know that this length between 1 dash and 7 dash happens to be 40 millimeter. And this depth across the edge 1 dash 1 1 dash, this happens to be 32 millimeter over here. So now we have to locate the center of this arc. So from this point A dash over here, we are going to mark one arc over here having radius is equal to 48 millimeter. Similarly, from the point 7 dash over here, again we'll open the compass having radius 48 millimeter, draw another arc through this point 7 dash over here. So wherever these two arcs they intersect, the center point corresponding to the circular cut section plane, it has been located over here. Now with this as the center point, we'll open the compass is equal to radius 48 millimeter, and once we draw this arc, so we have been able to obtain the orientation corresponding to the circular cut section into the front view projections over here. So now this portion of the vertical cylinder has been taken off or it has been removed by the cut section plane over here, and this circular cut section plane, it is going to intersect with all the 12 vertical generators of this cylinder into the front view projections over here. Now we are going to mark all of these 12 points of intersection into the front view projections over here. But before that, we can see that if we are going to open this cylinder from the point 1 over here, so we know that this is one sector length over here from 1 to 2, 2 to 3, 3 to 4. So all these sectors, they will be having the equal length over here. So using the parallel line development method, now we are going to obtain development of the lateral surface of this truncated cylinder over here. So from the base points, we have drawn a horizontal projector line over here. Similarly, from the top face points, we have drawn a horizontal projector line over here. Now, corresponding to each one of the sector, now 12 divisions we have been able to obtain over here. So starting from point 1, we can see we have marked point 2, point 3, point 4, 5, 6, 7, 8, 9, 10, 11, 12, and then again 1. Because we started from 1, so all these points of the circumference, they have been obtained into the development view over here. So the height of the cylinder, we already know this is equal to 64 millimeter. Now this sector length we are going to measure over here, and all these sectors will be having the same length over here. Why? Because the sector included angle corresponding to these 12 sectors happen to be equal, which is equal to 30 degree over here. So now we have been able to obtain all the vertical generators into the development view over here. So this is the development of the uncut cylinder as it is resting on its base onto the ground, and this cylinder is standing upright having height is equal to 64 millimeter over here. Now we see that this circular cut section plane, it has intersected with the 12 generators of this upright cone over here at 12 points over here. So let us obtain all of these 12 points as the cutting plane has intersected all of these vertical generators of the circular cylinder into different positions over here. So we can check the vertical generator 1 dash and 1 1 dash. It has been intersected by the cutting plane at the point A dash over here. So now once we draw a horizontal projector line through the point A dash of the elevation projection view, now we can check this point A dash we need to obtain onto the vertical generators corresponding to 1 and 1 1 over here. Similarly onto this generator also 1 and 1 1. So the point of intersection which we have obtained into the front view projection, so this has been transferred over here. So now the point A has been obtained into the lateral surface development view over here. Similarly, we can check the vertical generator 2 dash and 2 1 dash. It has been intersected by the cutting plane at this point, which is B dash. Similarly, the vertical generator 12 dash and 12 1 dash. It has also been intersected by the cutting plane at the point L dash over here. So both the points B dash and L dash, they have overlapped with each other at this position. So now from these 2 points of intersections, that is B dash obtained on the vertical generator 2 dash to 1 dash, and L dash which is obtained on the vertical generator 12 dash and 12 1 dash over here. So from this point of intersection, again we have drawn a horizontal projector line. So wherever this second horizontal projector line drawn through the points B dash and L dash, it is going to intersect with the vertical generators 2 to 1 and 12 12 1 over here. So the 2 points B and L will be obtained over here. So we can check point B has been obtained as a result of intersection of the cutting plane with the vertical generator 2 to 1. Point L has been obtained by virtue of the intersection of the cutting plane with the vertical generator 12 12 1 over here. So now the next 2 points of intersection, they happen to be C dash and K dash. So C dash point happens to lie onto the vertical generator 3 dash and 3 1 dash, whereas K dash point happens to lie onto the vertical generator 11 dash and 11 1 dash over here. So the points C dash and K dash, they have again overlapped with each other. So now once again, if we draw the third horizontal projector line through the points C dash and K dash into the lateral surface development view, so wherever this horizontal projector drawn through the points C dash and K dash, it is going to intersect with the vertical generators 3 3 1 and 11 11 1 into this lateral surface development view. So the points of intersection will be providing us with the location of the points C and K in the developed surface view over here. Now the next couple of points which we are going to obtain by virtue of intersection of the circular cutting plane with the vertical edges 4 dash and 4 1 dash and 10 dash and 10 1 dash over here. So again, two vertical generators, they have overlapped with each other over here, and the corresponding point of intersection of the cutting plane with these two vertical generators, they will be D dash and J dash over here. So D dash is the point of intersection of the cutting plane with the vertical generator 4 dash and 4 1 dash, and J dash, it is the point of intersection of the cutting plane with the vertical generator 10 dash and 10 1 dash over here. Now wherever this horizontal projector line drawn through the 2 points D dash and J dash over here, it is going to intersect with vertical generators 4 4 1 and 10 10 1 over here, will provide us with the location of the points of intersections D and J into the developed lateral surface view over here. Now the next 2 points of intersection of the cutting plane with the vertical generators 5 dash 5 1 dash and 9 dash 9 1 dash happen to be E dash and I dash over here. So now once we draw a horizontal projector line through these 2 points E dash and I dash from the elevation projection view into the developed surface view over here. So the point of intersection of this horizontal projector with vertical generators 5 5 1 over here and 9 9 1 over here. So wherever we obtain these 2 points of intersection, now points E and I, they have been obtained into the development of the lateral surface view over here. Now the next 2 points, they happen to be F dash obtained on 6 dash and 6 1 dash and H dash obtained on 8 dash and 8 1 dash vertical generator over here. So now we have obtained 2 points of intersection at this position. So now once we draw the horizontal projector line through the points F dash and H dash into the lateral surface view, now wherever this horizontal projector line, it is going to intersect with the vertical generator 6 6 1 and the vertical generator 8 8 1 over here. So the 2 points F and H, we will be able to appropriately locate into the lateral surface development view over here. And finally, the last point of intersection of this cutting plane, it lies on the top surface of the cylinder over here. That is point 7 dash and G dash. They have coincided with each other. So now G dash, it is the point of intersection of the circular cutting plane with the top face of this truncated cylinder over here. So we can say that the vertical generator 7 dash and 7 1 dash, it has been intersected by the circular cutting plane at the point G dash, and G dash coincides with 7 dash. So once we draw a horizontal projector line through the point G dash into the development surface view, now it is going to intersect with the vertical generator 7 7 1 at the top point over here. That is, point G will be lying adjacent to point 7. It is going to coincide with point 7. So this way, all the 12 points of intersection, they have been appropriately located into the developed surface of the cylinder over here. So now if we join all of these 12 points, now we have been able to obtain the development of the truncated cylinder top surface, where the cylinder had been intersected at different points by this circular arc over here. And now we can see this portion of the cylinder has not been intersected. So now we can join A11, we can join A11 over here. The cutting plane has not at all intersected with any one of the base points of the cylinder. So we can join all of these points of the base as such. So this way, we have been able to obtain the development of the lateral surface of the truncated cylinder, which has been cut by a circular cut section which is having radius is equal to 48 millimeter. So this is all for today. So I hope that through this discussion you would have understood about the procedure, how do we obtain the development of the lateral surface of a cylinder which has been cut by an asymmetric circular arc over here, because we can check this distance was 40 millimeter and this distance happened to be 32 millimeter. So first of all, we had to obtain the center point of this particular circular cut section over here. So we are going to continue with further discussion regarding few more illustrative cases of development of the surfaces of the solids in the coming lectures. So thank you very much. Thanks a lot.